We present a visual haptic display that enhances the experience in data visualization application using an adaptive vibrotactile physicalization process to convert information into vibration patterns that the user feels on top of 2D chart. We use two modes of data haptization, the third mode which relates to the sum of the COVID-19 data for each of the South American countries. It determines the maximum amplitude of vibration according to the country with the highest total value for the year, focusing on a comparison between countries. In this mode, each actuator is independently based on head position, making it possible to detect borderlines and their shapes, easing the data comparison of different countries. In the monthly mode, the COVID-19 data of the country being selected is haptically displayed mode by mode. A maximum amplitude of vibration is defined according to the mode with the highest value for that country. This mode uses a vibration transition that identifies each mode, with all the actuators being linked to the same signal. In this manner, users can easily identify the different waves of COVID-19 case and death in each country, month by month. For this work, we are using data provided by Johns Hopkins University. The user of our system can explore charts and graphs either on a video monitor or on a printed paper, being able to feel vibrotactile patterns on the back of their hands via a glove that communicates all the dimensions of the data at that particular point of interaction that is not visually displayed, either adding to the data visualization or enable people with visual impairments to understand it. In the printed paper approach, by touching the data visualization with a finger, the system recognizes the interaction location on the chart by means of a set of 4 sensors placed in the corner of the supporting surface. Originally, we intended to use a plastic clipboard as a surface. However, we replaced it by a small glass surface of a picture frame since its rigidity presented more stable regions. Since the use of the glass surface in 4 sensors during present acceptable position results in terms of accuracy with a PC ratio equation, we trained a regression artificial neural network in order to convert the regions into estimates of planar position the user is currently touching. Alternatively, by using a video monitor as a platform, the interaction can be done via mouse, which provides a more accurate position reading than the 4 sensors. Additionally, the user is able to change the data being displayed according to the number of deaths of case between the total and monthly change in data, as well as the year being displayed. A pixel art style was chosen for this map in order to facilitate the understanding of country borders across the 8 different vibration actuators, making it possible to correlate each actuator to a single pixel of the map. That is, it detects the 7 neighboring pixels to the right of the one selected and below. In this manner, we were able to map every country and its borders with higher fidelity. Color represents the country being analyzed in each actuator. Circle radius represents the amplitude of the vibration being displayed. For this, our approach can detect the orientation of lines and curves. It may also serve to provide visually impaired people to better convey maps and visual charts. In order to convey the passage of time in the data, a span of 1 second is taken to display the total deaths in each month. In this way, the user can feel the different waves of the pandemic that hit each country. A vibration pattern is displayed that identifies each month before the COVID data related to that particular month.